This video is for section 5-1, 0 and negative exponents. We're starting chapter 5 about rational numbers. To give meaning to expressions that have a negative number as an exponent or 0 as an exponent, we follow the same exponent laws from section 4-1. Here's a theorem. b to the 0 power is equal to 1 for every non-zero number b. So 6 to the 0 power is equal to 1. X to the 0 power equals 1 as long as x isn't 0. Negative 3 to the 0 power equals 1. Why is that? Let's make a justification. If we had a problem such as 6 to the 3rd power and divided it by 6 to the 3rd power and used the exponent laws from section 4-1, we would write the base and subtract the exponents, creating 6 to the 0 power. But because the numerator is exactly the same as the denominator, we know that these divide to equal 1. Therefore, something to the 0 power must be equal to 1 for math to be consistent. Here's another theorem. If n is a positive number and b is not 0, then b to the negative n power is equal to 1 over b to the n. For example, if we have 6 to the negative 2 power, that is equal to 1 over 6 squared. Or if we have negative 4 raised to the negative 1 power, that is equal to 1 over negative 4 to the positive 1 power. Let's make a justification of that. Let's say we had the expression 6 squared and divided it by 6 to the 4th. Using the law from the last chapter, we would subtract the exponents, getting 6 to the negative 2 power. But the meaning of 6 to the 2nd power is 6 times 6. And the meaning of 6 to the 4th power is 6 times 6 times 6 times 6. 6 divided by 6 makes 1 and cancels away. 6 divided by 6 makes 1 and cancels away, leaving 1 over 6 times 6, or 1 over 6 squared. Therefore, a negative exponent must be equivalent to a reciprocal of a positive exponent for math to be consistent. Let's do some example simplifying problems where we're using the laws of exponents. Whenever you are asked to simplify a problem involving a fraction, that automatically includes writing positive exponents only. First example, b to the n times b to the 0. Using the theorem from today, b to the 0 is equal to 1. Therefore, the answer is b to the n. Next example, n to the 1 divided by n to the 2. To divide powers, subtract the exponents, creating n to the negative 1. And using the theorem from today, that is the reciprocal of 1 over n to the positive 1. I'm not going to actually write an exponent of positive 1. Next example, 1 over v cubed raised to the negative 4. Using today's theorem, a negative exponent is equivalent to the reciprocal raised to a positive exponent. Then simplify further. V cubed divided by 1 is the same as v cubed, raised to the 4th power. And then use the rule about multiplying exponents. Final example, let's simplify this. Start with the numerical coefficients. The 5 divided by 15 reduces to 1 over 3. Then the variable x. When doing a dividing problem, you subtract the exponents. Negative 1 subtract positive 1 makes x to the negative 2, which is equivalent to 1 over x to the positive 2. Now the variable y. Again, divide them by subtracting exponents. 3 subtract 8 is y to the negative 5, which is equivalent to 1 over y to the positive 5. Notice the final answer has only positive exponents. Let's summarize the lesson. We discussed what to do if you ever have 0 as an exponent. The expression is equal to 1. And we discussed what to do if you ever have a negative number as an exponent. Create the reciprocal and use a positive exponent.